Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome back to Blue Origin for part 2 of my tour with them. Now in part 1, we went inside the factory, saw where New Glenn's being built. It was amazing. If you haven't seen that, definitely watch it. But in part 2 here today, we'll see the massive midsection of New Glenn's booster. Then I'll be taking you out to the launch pad. We're gonna be going to Slick 36, where New Glenn will be launching from. We're gonna walk around and see all the crazy stuff. It's all just massive. They've got the Pathfinder out there right now. We'll even take you up the tower to see beautiful views of Cape Canaveral. And again, we have an awesome tour guide with Jeff Bezos. So let's get started.
We're building a big lunar building. You'll see there's some construction going up here. Putting up a big lunar building for building our lunar landers.
I love the plurality of lunar landers. That makes me happy.
I feel that too. I like that too.
It's exciting times we're living in. That's what's so cool is that
it's a golden age.
It is.
It's a golden age. It's really exciting. You'll like this. I have a strong feeling.
I have a little idea. I think based on the size.
This is the final assembly bay. So, hey guys, how you doing?
Howdy.
So, this is, so I showed you if you think with the aft section.
Yep.
And the forward section.
Yep.
This is the mid section. So this is the flight article.
Wow.
And this building is where the mid, the aft, and the forward all come together.
Okay.
And so this is, there's a Strake. This is that thermal protection cloth that we invented. This is a nickel alloy. This leading edge is just a high temperature nickel alloy.
So that won't need additional thermal protection.
This will handle the thermal. It's heavy.
Yeah.
That's why we don't use it everywhere.
Yeah.
It does the job, but it's heavy.
Yeah.
And this is very light. And we've tested it many times. So it will be highly reusable without refurbishment.
And this is the bottom of the Strake because it cants up a little bit here where the aft section has that skirt.
You're very observant. That is correct. Well done.
It gives you a sense of how big the leading edge is, though.
That's where the Strake gets attached.
Oh, crazy.
And this Strake more than pays for itself in terms of landing propellant savings. Yeah. Isn't that amazing?
Well, it makes sense. I've actually done it. I don't know if you ever played Kerbal Space Program or seen it at all.
I have. I'm not good, but I have. One of my kids is very good.
Really? Oh, yeah. That's cool. It's such a fun tool or game, you know.
It's fun.
For learning some of those things. And I remember, you know, at some point you start playing around with that kind of stuff and you realize, wow, the atmosphere can do.
A little more subtle and not as big an effect. It helps on ascent.
Really?
Because it gives us lift.
If you kind of fly a little bit
it's
into the
very small.
Yeah.
But you fly at a slight angle.
Huh.
And it's like an airplane wing.
No way.
It gives you lift.
Yeah, makes sense.
You're basically stealing momentum.
Right.
From the air. So, this is the tunnel.
Mm-hmm.
So, these big lines, one of them is autogenous pressurization for the LNG tank.
Yep.
And one of them is autogenous pressurization for the aux tank.
Yep.
So we're taking hot, it's warm, it's not really hot.
Yeah.
We're taking warm GOX and putting it into the aux tank, and warm LNG gas and putting it into the LNG tank.
I love that.
And so, and then the other one is, the other tunnel is for nitrogen.
Yep. And so nitrogen needs to go down that way because it still is maybe using the engines as a heat exchanger.
Yeah, and it's used on both sides of the vehicle.
Okay. And
so if we walk down, you can actually see. So we can tell which one of these So see, you can tell the center one is the GOX.
Yep.
Because this is the OX. This is the
Yep.
LOX tank.
Yep.
The LOX tank is on the bottom.
Okay.
The LNG tank is on the
top.
And do you know why? So
Is it LOX
is 3 times heavier.
Yeah.
Right. So a little more actually, 3.1, 3.2, something like that. And so you care a lot about the structural loads. And if you can keep the structural loads on the bottom, if you can keep the heavy things on the bottom,
right. You don't
have to carry those. If we put the LOX on the top, then the LNG tank walls
would have to
we have to carry all of the load
Right.
for millions of pounds of LOX.
Right. So if you invert it, it's just
So this way, you want to the degree that you can do so.
Yeah.
You want the heavier things on the top. I mean, so the lighter things on the top.
Right. Yeah.
And the heavier things on the bottom, because that would be more structurally efficient.
Yeah, kind of like a pyramid almost.
Yeah, you've got 4 million pounds of thrust, almost 4 million pounds of thrust pushing.
Yeah.
And so anything heavy up high is going to force you to have more structural integrity to react to those loads.
Yeah, yeah. And also...
Now, there's nothing you can do about the payload and other things. Those have to be high. You just have to accept that. But you can put the LOX on the bottom.
Yeah.
And then there are other things that can come into play, especially with doing a vertical landing. You do need your center of gravity to be high enough that you can maneuver the tail of the vehicle under your center of gravity. But that all works out in this case.
And also having a low center of mass helps to, at least on the way back through entry, makes it more stable.
You want your center of pressure to be behind your center of mass for stability. So there's a bunch of aerodynamic things too.
Yeah.
But if all those things work with the LOX on the bottom, LOX on the bottom is better.
Right. And I love, these are the trades and all these little I would love to just sit on these meetings and just hear people, debating on them. So we must be right around the common bulkhead here then if
yes, this is exactly right. The common bulkhead, this is the top. This ullage is coming in at the top of the OX tank.
Yep.
So the common bulkhead is right here.
And so then are these where the umbilicals, the propellant umbilicals, or what are those huge old...
These are vents. So these these are going to be they'll be aux vents.
Wow.
So so they'll be routed to the exterior of the vehicle.
That's crazy.
So they're probably mostly used during fueling operations.
Right.
On the ground.
Yep.
But you try to minimize venting.
Right.
In space, I mean, we're really talking more about the second stage now.
Yeah.
This stage, you don't want to do much venting here either, but venting is kind of waste, but some of it can't be avoided. On the ground, it doesn't matter.
Of course, right. Jeez.
And so this is the ullage for the LNG tank. And there are, the last in the sequence here, these are slip joints. All of this, we're not looking at the details, but obviously this tank gets filled with cryogens. And so it stretches and contracts. This length changes quite significantly. So when you look at, there have to be slip joints for these lines.
Wow.
Because they are made of a different material. And they're also, they don't operate at the same temperature.
Right. So they're going to change.
So they're going to change length differently than the tank. So all of these, see these white rings?
Yeah.
Those are this thing is mounted inside there, but it slips on that. Those are slip rings.
So the whole entire pipe can basically slide up and down.
As the tank length changes. And then it gets taken out here.
Can you imagine having to be an engineer and go, well, it's going to be, 300 feet at this temperature and then 302
It's very significant. Yes, it is like that. And this is why all of the interesting stuff happens in the details.
Yeah.
This is a perfect example. You think, we'll just run ullage, autogenous pressurization.
Yeah.
We'll run a line up the side of the vehicle. And you're like, well, that line has got to stretch. And it can't be fixed firmly to the tank or it'll rip itself apart.
Oh my gosh, that is crazy.
Isn't that interesting?
It really is.
But personally, I love the engineering details.
Right, yeah.
To me, that's where all the fun is.
Yeah, 100%.
Hey guys. Hello, hello. So here, you can see, so this is where the forward module will get attached. We went inside that.
Yep, yep.
And so the forward module gets attached here.
This thing, I mean, this is already a huge vehicle. And
this is just the midsection.
Just the midsection.
So you attach an aft section, a forward section, and then a second stage, and then a payload fairing.
Yeah, this is huge. This, I mean, again, people for scale there. And then the whole entire room down there. That is crazy. Oh, and when it's fully integrated, it's gonna be magical. Jeez. Do you guys, when's that Escapade launch window again? Is that?
October.
October.
Yeah, you can, I mean, it's just the Mars transfer
window.
Right,
just the Mars transfer window.
Yeah.
Are you feeling like you'll be able to?
I mean, there is some, because we have excess performance, we can go kind of late in the Mars transfer window.
Yep.
So the Mars transfer window it's not like a day.
Right,
It depends on how much delta V you have.
Definitely.
You can go later if you have more delta V.
Yep.
So we have a little margin.
A little there.
But yeah, shall we go to the pad? Yeah, let's go to the pad.
Let's do it. So we headed out and made our way from Blue Origin's production facility on Merritt Island. It's actually right next to the Kennedy Space Center Visitor Complex. A little more than 10 miles to the launch pad, which is Launch Complex 36 on Cape Canaveral Space Force Station. Now you probably noticed that Jeff and I were talking about some pretty interesting physics problems with the expansion of materials and thicknesses of walls and so on and so on. And today's sponsor, Brilliant, can help you learn more about math and physics in an intuitive way. Brilliant is where you learn by doing, with thousands of interactive lessons in physics, math, data analysis, programming, and AI. Brilliant emphasizes hands-on problem solving and a first principles approach to help you build a deep understanding of concepts. This method of learning is shown to be 6 times more effective than traditional lecture videos. Brilliant's content is developed by an award-winning team of educators and experts. Personally, I'm a very hands-on visual learner, and being able to see concepts and interact with them is honestly by far the best way for me to learn. And Brilliant presents their lessons in a way that makes absorbing the information easy and fun. For instance, they have a new course called Exploring Data Visually that would be perfect for anyone who watches my videos, because I often use graphs and charts to illustrate the reasoning behind some of the decisions that engineers make as they design hardware for spaceflight. This course can help you strengthen your ability to comprehend data at a quick glance. You can try out Brilliant completely for free for a full 30 days by going to brilliant.org/everydayastronaut, or just scanning the QR code on the screen, or just click the link in the description. You'll also get 20% off of an annual premium subscription. Thank you, Brilliant, for sponsoring today's video. Okay, time to go check out that launch pad.
This is the integration facility.
Look at the size of these doors. Oh, wow.
You can see a big fairing down there.
Holy cow. Hey, and if you want, I'm gonna stand back and get a shot. You stay here. I wanna get the size of this compared to, this is crazy. Look at that. I'd have to get like, that is insane. This building is enormous. It's just crazy.
Pretty cool, right?
It's really cool. And that fairing, I mean, from here it looks like not much, but it's, again, you got a little tiny person out there. This is insane.
So this is where, you know, you can basically put everything together.
Yeah.
Second stage, first stage, booster, etc.
Yep.
Encapsulated payload. You can integrate everything here.
Yeah.
And then it all gets integrated on this transporter.
Okay.
So we'll see, we're gonna go out there, but you would do that in here. This is a mass simulator that's out there right now.
Yep.
And we're using it to do a bunch of wet dress rehearsals on all the ground infrastructure. That's what's going on right now.
Okay.
But I'll show you. We'll jump in these vehicles and you'll see up close.
Awesome.
At the end, remind me, and I'll take a selfie with you here at the Road to Space side.
That's awesome. Interplanetary, even. Wow. That is. We're moving, but it's not getting any closer. Man, and the craziest thing is how well you can see this entire complex from Cape Canaveral. The public's gonna have the best view of this launch.
All right, we can get out and walk from here.
Wow.
So this is the transporter erector.
Yep.
And so it both transports the vehicle out here and it uprights the vehicle.
Yep.
Transporter erector.
Transports and erects.
That's a payload mass simulator.
Okay.
And it also adds some vibration. It's a kind of a sophisticated simulator that can shake things around.
Okay. Oh yeah, I can see like actuators or something on there that.
This is a mass simulator for the second stage.
Okay.
And then this is a simulator for the booster.
Jeez. So this just wheels up freewheeling. There's no track. Like there's no
track. This thing can crab sideways. It's incredibly maneuverable.
So then you precisely maneuver it to the pad.
To the pivot point. So you maneuver it up here. I'll show you. So you maneuver it up to a pivot point. A giant hinge kind of locks it in place. And then there are huge hydraulic actuators.
Yeah.
Underneath.
That had to pick that all up.
That basically lift this into vertical position. And in fact, most of the weight is the transporter erector because it holds the vehicle. The vehicle is very light at this point because it has no propellants on board.
Right.
It only weighs a few 100,000 pounds.
Yep.
But this structure is designed to keep the vehicle extremely rigid. You don't want to put bending loads into it while you're transporting it or while you're erecting it.
Yep.
And so this weighs 4 million pounds.
Oh my God.
So the vehicle weighs a few 100,000 empty.
Yep.
This weighs 4 million pounds. And so the actuators have to be sized to lift all of that mass. That is. There's another one of those things that, we've seen the renders of this mechanism and this vehicle and how it's going to be flipped up, for years, and then just to see it in person is absolutely crazy. That's the pivot point. That's the hinge.
So the vehicle actually ends. Where's the vehicle end and the pad begins? Is even the base here?
That's the pad. So basically, picture that this whole thing in here. If I come up here for a sec. I'll show you. It'll make more sense. See those two? Those are giant hydraulic actuators.
Wow.
They're underground, so you can just see the tops of them.
Okay.
But underground, right under there, they are I think they're the largest hydraulic actuators that this company ever made, maybe ever. I don't know. But those things push. They go up.
Yeah.
And when they push up, this whole thing rotates around this pivot point.
Wow.
And so then that ring right there ends up laying on these attachment points.
Jeez.
And that ring has the T0 release mechanism built into it.
Okay.
And so it comes down and it gets clamped in place there's some mechanisms over here. that clamp that in place. But that's not a T0 mechanism.
Got it.
That's like it clamps it in place to hold this ring down, and then this ring has the T0 releases built into it. Wow. All of the umbilicals, all the umbilical attachments to the vehicle are integrated in the integration facility on this transporter erector. So the transporter erector, you get to do all of the detailed, umbilical work in that air-conditioned environment. Like, conditioned environment, clean.
Right.
And then when you come out here, all that work is already done. You upright the vehicle, all the umbilicals are already attached.
It's ready to go then.
It's ready to go. Here, we can go around, give you another view a different way. The ground infrastructure is one of the unsung heroes of launch. Oh yeah, there's the flame duct.
Oh my God.
Water cooled.
Look at this, like that's a whole jib down there. That's like, that thing's huge. Oh,
high pressure water. There are holes all over that. High pressure water comes out and keeps it cool, and it also suppresses noise. So it's the harshest environments for a launch vehicle and for its payload happen on the pad, because you've got full thrust from the engines, and it's all being reflected off of the launch infrastructure. And all of that reflected noise is going up and shaking and rattling everything at kind of full spectrum. And so it's a very harsh environment. And so you do everything you can to minimize that environment. And that's a lot of it's for both thermal protection, you have the water, but a lot of the water's purpose is to damp out as much of that acoustic energy, that harmful acoustic energy as you can. That's what these things do too.
Yeah.
They shoot water. High pressure water shoots out of these underneath. You can see it over there too. And that's really acoustic energy suppression.
And that shoots, the rainbirds cover the deck, basically.
Cover the deck.
Yeah.
And so you've got water coming in here, you've got water down there. All of that is absorbing acoustic energy.
And the water tower you guys built, if I recall, might be the tallest water tower ever
As
made,
far as we know, it is the tallest water tower in the world.
That on its own is pretty crazy.
These towers are 574 feet tall. These are giant. Wow. This one is, this one is for access, vehicle access and so on. This one is for the lightning arrestor system. Here in Florida, you definitely need lightning arresters.
Yeah.
Let's go up here. We can peek. Hey guys.
Hey, how are you? Jeff.
Yeah.
If you could just up to the top of the platform but not past the gate without fall protection.
Is it okay for two of us to be up there?
Yeah, for the two. Yeah.
Come on up. You can stand right here next to me.
Okay.
It's just a cool view up here. And you can see, so now I think you get a better idea for when the vehicle gets erected, it hinges.
Yep.
And it comes down and it attaches to these bunkhouses here. Inside these bunkhouses are these giant hydraulically driven mechanisms that basically lock that ring in place. And then that becomes the real launch pad. All the engines fire through that ring, down through that hole, right onto the flame deflector.
That is magnificent. Oh, God. So is that ring actually, you'd think that thing would get beat up pretty good. Is that going to be an expendable ring, or is it?
No, it should be okay. It's because most of the, first of all, we have these rainbirds coming in, but that's not the main thing. It's just that the engines are actually firing right through it.
Yeah.
And so it's where the plume impinges.
When it comes in contact with something.
It's 5,000-6,000 degrees Fahrenheit. It's a acetylene cutting torch.
Yeah. A flying giant skyscraper.
4 million pounds of thrust.
Yeah.
So it's everything in its path wants to be destroyed.
Yeah.
So there you go.
That's crazy.
All right, shall we?
Yeah, let's do it.
I'll take you up in the elevator.
Oh, awesome.
Yeah, let's go up.
I don't think we could have picked a better day to be out here for this.
Perfect day.
This is perfect. I love when there's
By
like
the way, it's not even that hot.
No, it's actually nice
It's pretty
for once.
nice. It could be hot.
Oh, yeah. This is fantastic.
Late May in southern Florida, it can be hot.
Oh, yeah. Oh, yeah. It can be nasty. This is great.
Look, you can still see the fairing over there.
The fairing
peeking
is
through the door.
massive.
So we're gonna go. We'll go down, and then we'll go over to this elevator.
Cool.
And we'll go, not quite to the top of the tower, but almost to the top.
Awesome. So the tower's purpose, though, yeah, is New Glenn gonna fly humans at some point?
Yes. So I mean,
Wow.
at some point, yes, and that is what that tower is for.
So you guys
It's
thought
also-
that far ahead and
It's
planned.
also lightning arresting
Yeah.
and other things, but that's a few years. That's a bit out there.
Yeah.
I mean, we're really focused right now on the cargo missions.
Yep. But I like how far ahead you think. It's it's not just what do we need to do right now. It's what do we need to be doing in 5 years, 10 years time.
Absolutely. And you do need to think ahead because these things take time.
Yep.
Oh, we'll take a map just in case.
Oh yeah, we were talking about
Why
wanting
not?
to check out the pads.
Sure, thank you. That's very
all.
nice.
Help us figure out which pads we're looking at
Yeah.
from up there. So, looks like a lot of the commodities are flowing. Or is this all going into the? Is this all like data mostly, or is this?
This you can see that's the oxygen side. There's LNG over there, and then behind that wall is liquid hydrogen.
Wow.
We'll see it better from up
Yeah.
high. There's some of the big transport lines right there.
Oh yeah, those are huge.
They're all vacuum jacketed.
Right, because they don't want to have boil off.
You don't want to have boil
You don't
off.
want to lose your propellant before it gets into the vehicle.
Come on in.
Awesome. So, how tall again did you say this tower is?
574 feet.
574 feet. So almost about 190 meters or so, 180 or something. Or wait, yeah. Jeez. This is gonna be quite the view with the rocket.
You're not afraid of heights.
I'm not,
All right,
fortunately. that could be bad if I just panic right when we get there. You obviously aren't. 'Cause you've been above the Carmen line, so
True.
you've gone higher than most people. It's probably a little slower than New Shepard, I imagine.
Yes.
This elevator.
No doubt. Yeah.
What's wild to me is that this pad went from nothing probably
This is Greenfield.
4 years ago or
Yeah.
something. I mean,
Totally.
I remember starting to see signs of concrete work, and all of a sudden you're seeing a line of concrete trucks come for miles because
Total Greenfield.
And-
We'll see it better from the top, but that's the original blockhouse
Oh, okay.
there. See that big round building right there?
Oh, yeah.
That's the original blockhouse.
That
You can
is?
see the periscopes.
Yeah, the little things sticking out the top or the periscope. That's crazy. I didn't realize it was a circle for some reason. I just imagined it being a.
They had, because their camera gear was so bad, they just couldn't rely on it.
They
They
just
had
used
to
old
like
school.
keep people physically close by. They did. These guys that worked in there though, they did have an escape tunnel, so they didn't have to just weather if the vehicle exploded and the roof is burning and all that. They could actually scuttle out through an escape tunnel.
Really? How far does that go?
I don't know. A couple hundred yards.
You should explore that someday.
Apparently, it's in pretty bad shape.
I imagine after all this time. That's what just fascinates me about the whole Cape. You have to imagine how many things there are like that are just lost to time, that are just rotting away, but have so much history. And
Have you ever the Winston Churchill bunker in London?
I've
Just
never
when you're on
visited it.
vacation sometime, you should go check it out because that's what it is.
Yeah.
It was his bunker where he ran the war effort from there.
Wow.
And they built it secretly during the war, this like giant bunker. And you know, the day the war ended, they put a padlock on it, and nobody opened it until like 1974.
Really?
So they opened it, and they're like sugar in the teacups, and cigarette butts, and all the maps of where they thought the U-boats were, and everything. It's like completely preserved.
Wow.
And it's really interesting.
And I assume they kept it that way still, right?
And then they kept it and turned it into a museum.
That's really cool.
So it's one of the best museums I've ever been to.
I gotta visit that. Wow.
But it's one of those accidental museums.
Yeah.
Because they're like, we're
They
done.
didn't know,
They put a padlock on the door. They just left. Didn't need it anymore.
The view of the Cape from here, I can't wait until we're out of the elevator.
Oh yeah, it's really extraordinary.
It's insane.
Yeah, I'll let you hold that and I'll take it in a minute. Thank you. Are we here?
We are here.
Sweet.
All right. Come on out.
Jeez.
Right?
This is incredible. The Cape looks, this is the best view I've ever seen of the Cape.
So here, don't drop your camera.
Yeah, I'm gonna switch to this
But
side.
this gives you a really good view of what we just looked at. So
Oh my
you can see
gosh.
the mounting points. You
Yep.
can see the flame duct.
Yep. Jeez. Then you get a sense of how far away the hangar is.
Mm-hmm. We're at the southern tip, so
Yeah.
that's actually the last pad.
Well, that's what's so great is that people that are, so Cocoa Beach there and Cape
Right.
Canaveral, I mean, they're going to have the best view in the house is actually going to be the public at Jenny
Right.
Park right there.
It's going to be amazing.
They're going to be closer to that than, or about as close to that as like
And
you are when you're,
We're also,
you know,
there's the port. So the port is right there.
Yeah.
So when the vehicle comes back,
yeah,
it doesn't have to go very far.
doesn't have to go very far. And think about all the people on cruise ships that'll have a view too of a launch. I mean,
So true.
Jeez. That's
so
going to
true.
be spectacular.
Like,
Man, these the lightning resting tower things are
isn't that
just
crazy?
insane. They're so big.
Yeah, no, it's crazy.
Jeez. Just to think, I mean, this hasn't been here that long, you know? I mean, we're
No, it's brand new. It's brand new and awaiting its first use.
it's
And look how
incredible.
pretty this is.
Yeah.
Somewhere down there is that beach house we were talking about.
Yeah, the Astronaut
I think
beach
it's
house.
on that point, but I'm not 100% sure.
Yeah, I know I shot a launch from a vantage point right where that's like kind of next to you for a Delta IV Heavy mission, and it was an incredible spot.
LNG,
Oh, yep.
LH2, liquid
Yep.
hydrogen, and then just over there, you can just barely see it through there.
Oh,
is
yep.
LOX. So those are the three big commodities. All this, you see, just like so much. Look at all this vacuum jacketed
Yeah.
transport lines. Crazy.
Jeez.
This is actually a really good view of the uprighting system here too.
Yeah. You get a sense of those huge clamps.
Yeah.
Wow. Oh man, this is crazy.
Yeah, that thing has to be structurally designed to support the fully fueled vehicle plus the transporter erector.
Oh,
Or
at least a portion of
at
it.
least a portion of it. The erector part,
Jeez.
yeah. I think if we go over here,
Yeah.
we can see a lot. This is a good view. So this is the thing,
Oh my
they call this the
gosh.
blockhouse, and you can see the 4 periscopes there.
Yes.
And that thing, when we opened it up, it's like completely full of asbestos. It's just
Oh.
like 'cause it's all built in that era.
Yeah.
And so it's like, and it's a mess inside, but we remediated a lot of it. It'll never be used for
Right.
anything. It's not really useful. But
can you imagine seeing a new Glenn launch from there?
That would be incredible.
that would shake.
Be truly incredible.
Oh, that'd be insane.
Yeah. And this pad, LC36, is where Surveyor, Mariner, a lot of the early pioneering missions launched from right here.
Yeah.
And then I think the last launch from here was in the mid 2000s. Can't remember what it was. And then it sat dormant until we built this. So
this is crazy.
It's like Bezos will have been dormant for almost 2 decades.
Right.
About to come back to life.
Well, it's cool that we're looking at so much history right here. We have the vehicle assembly building out there.
Yeah. By the way, this is where Falcon Heavy, when they did the dual.
Oh, right there.
The dual landings, they land right there.
That's cool.
And then you can see. I think that is the big building you see here. I think is LC37. That's the Delta IV Heavy pad.
Yep.
Which is being decommissioned and be used for something else at some point. By the way, we need to build a second pad. Yeah. Because we need it both for redundancy, and we need it for cadence. Yeah. So that's Delta IV Heavy.
Yep.
Yeah. Then you can see all of the incredible history out there.
Yeah. I mean, just seeing the
that's
VAV
SLS now.
Yeah. Seeing the VAV from here is just crazy. It looks so ominous just out there on its own. And then you've got 39B and A. Right. And Starliner's on the pad as we speak right now, which is crazy.
When does it launch? A couple days?
A couple days from now.
Yeah, when you're doing this, yeah.
That's crazy. Now that, and we have all this history here, what I gotta ask, okay, so you've been in this now for, let's see.
I give this up. Thank you, Neil.
When was Blue Origin founded again?
2000.
So you've been at it?
Yeah, I mean, that's when we started. It was very like a R&D program. Mm-hmm. We were looking at all kinds of interesting launch ideas back in the old days. I'm sure. Like looking for everything that you could ever imagine in terms of how to beat chemical rockets. Right. And after 3 or 4 years of looking at every ingenious idea, it became obvious that only reusability mattered. Like you don't need to. Chemical rockets are fine for Earth launch, and you just need to be able to reuse them, at least the booster stage. And then we looked at different reusability architectures and decided on vertical landing. And then we built several prototype vehicles. Charon, which is in the Seattle Museum of Flight, was our first vertical landing vehicle. It's actually jet powered. Oh, really? Yeah, it's cool. It's the coolest looking vehicle I've ever seen. You can go see it in the Seattle Museum. And then we built something called PM1, which was our first propulsion module, vertical, took off and landed vertically.
And that looked kind of like a New Shepard capsule, didn't it? Was that the gumdrop shape
yes,
thing?
Yes, it is. Yep. You got it. We built PM2, which got to altitude, but then lost its hydraulic system, and so it didn't land, it crashed. And then we built PM4, which is New Shepard. Okay. PM3 was a design that we decided not to build. And so PM4 became New Shepard. And then it's now flown 6% of all the people who've ever been above the Kármán line have flown in New Shepard. So we're
and counting.
Yeah. So that's very exciting. And then and then this year we'll fly New Glenn. So that's sort of the trajectory so far of the last 2 decades.
And with those 2 decades of hindsight, almost, would there be anything you'd have done different if you called yourself from 20 years ago and said, all right, here's what I want you to focus on right now? What would there be anything you'd change?
There's tons of technical learnings. If you could skip steps on technical learnings, which you can't, of course. Right. But the real transition, I would say, for Blue started we really are moving, starting about 2 years ago, from an R&D phase to a rate manufacturing phase. So what's happening now is that we are becoming, our goal is to be the world's most decisive company and to be one of the best companies in the world at rate manufacturing. So the it's all that piece of it, to sort of the how do you design things and sort of the R&D phases of things, but to really be launching, hundreds of times a year, that's about production, rate manufacturing, operational excellence. Mm-hmm. It's much more like my Amazon job, where it's all about operational excellence. If you talk about AWS and running gigawatt scale data centers, or you're talking about shipping 10 billion packages a year, mm-hmm. it's about finding defects, finding root causes of defects, eliminating those at the root, and really driving for operational excellence. Yeah. So world-class manufacturer is the next stop on our journey.
Yeah.
And hopefully you saw some of that today.
Yeah, I mean, I think you're in the right place for that so far. I think you're doing pretty good.
Because we talked about this a little bit earlier, but I remind people of this every time I get the chance, which is space travel is a solved problem. Mm-hmm. It's been solved for 50 years.
Yeah.
What's unsolved is the cost.
Yeah, that's true.
So we know how to travel to space. Mm-hmm. We know how to land on the moon. Mm-hmm. We need to be able to do it 100 times cheaper.
Yeah.
So that's what will really open the heavens to humanity. Mm-hmm. And that's what will really make it possible for there to be the kind of entrepreneurial dynamism in space that I just got to witness up close and personal over the last 20 years on the internet.
Right.
So on the internet you have this giant ecosystem of incredible dynamism. Big companies, medium companies, small companies, everybody doing startups. Like, there's so many winners, and every experiment gets tried.
Yeah.
And that's what I want to see happen in space.
Yeah.
But to do that, we need to build better infrastructure so that real entrepreneurial zeal can work.
Yeah.
Because if the minimum size to do any useful experiment is many, many millions of dollars, then you just can't get, two kids in a dorm room making the next amazing invention.
Right. The barrier of entry is too high.
The barrier of entry is too high. And so my visualization for this is, can two kids in a dorm room build the next, giant space company?
Right.
If they can, then we did our jobs right.
Cool. That's awesome. And I feel like that's kind of been your transition, because you've been spending a lot more energy and time with Blue now. You're kind of...
It's the primary reason that I left my CEO role at Amazon is so I could focus on Blue.
Yeah.
And so that's I'm still very involved in Amazon, mostly on the AI side, but Blue is really where I'm putting the vast majority of my productive efforts. And I'm working harder than I ever have.
Really?
And I'm enjoying every minute of it. I'm working so hard, and I love every second of it. I'm like zero complaints, even on the bad days.
Yeah. That's awesome. I mean, and when you end up, seeing the work pay off, and you're seeing all the infrastructure, and you're seeing the vehicles preparing, and you're seeing the pad, the payoff with launch is going to be
huge,
spectacular.
The emotional payoff will be gigantic.
Oh, you're going to probably crash. You're going to sleep for a week after it finally launches off it.
And I'll also be a nervous wreck ahead of time.
Yeah, you will. Yeah, you will. But that's going to be But like I said, I mean, just even with this, where we're at in the Cape and everything, I don't think people need to know how cool this will be for launch to see for the general public.
It'll be incredible.
It's when you're walking.
And regardless of what happens, I guarantee you it'll be exciting.
Yeah.
So we're going to launch this giant vehicle for the first time.
Yep, exactly. I mean, just walking up the beach, all you see is this pad. You see this pad straight on for miles and miles and miles, and it's going to be spectacular.
From the public beach. It's going to be amazing. It is like we are just gratuitously, fortunately, luckily, we're perfectly situated for public viewing.
It's going to be the best rocket to launch and view from out here at the Cape, honestly.
We're really lucky in that way.
Yeah, that is so cool. Well, Jeff, thank you so much for all your time, and I'm so excited for this program. I mean, it's going to be one of the most spectacular launches I think we're going to see anytime soon.
Thank you, Tim, and I really appreciate the work you do educating people on space and all the enthusiasm you bring to it. So thank you for that very much.
Thank you. I mean, we'll be paying attention. We'll be cheering for you guys every single second of the way. It's going to be awesome.
Thank you.
Thank you. My mind's blown. I'm frazzled. That was just unbelievable. And thank you so much to the teams at Blue Origin and specifically Jeff Bezos for all that generous time. I had an amazing time and I learned so much, and I'm so excited for New Glenn's first launch. So I hope you guys are tuning in and keeping up with the progress of this program, because it's, as you can tell, it's very exciting. And I owe a huge thank you to all my supporters. So those of you at Patreon and YouTube members and ex-subscribers, or however you're helping, even if you're just giving a thumbs up or a super thanks or whatever, it all makes a huge difference and makes videos like this possible. So head on over to patreon.com/everydayastronaut. And while you're online, be sure and check out our new merch, like this awesome F1 shirt as part of our 1969 collection. We've got a ton of really, really cool stuff that pays homage to the 1969 Apollo era. And you know, I believe we're kind of in a new Apollo era ourselves these days. So check it all out at everydayastronaut.com/shop. Thanks everybody, that's gonna do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.